Thus far, our work with the Fourier series has involved this double sum involving cosine terms and sine terms. There's an alternative trigonometric form to the Fourier series that's kind of interesting, and it's simple enough to derive that I think it's worth just a minute or two of our time to take a look at it. It's based upon the trig identity that the sine of an angle, sine of theta, is equal to a time-shifted version of the cosine, or the sine of theta is equal to cosine of theta minus 90 degrees. So all of these sine terms then can be written as cosine terms. So we'll have this first term here, or this first sum, just rewritten there. The second term then becomes this b sub n cosine of n omega naught t minus 90 degrees. Now, we can write this, or we can look at the nth term of each of these sums and add them together. And we have then the nth term will be then a sub n cosine n omega naught t plus b sub n cosine of n omega naught t minus 90 degrees. Now if we write these in phasor form, first of all in polar form, this is going to be a sub n angle 0 plus b sub n angle minus 90 degrees. Now to add those is most easily done if we write them in rectangular form, so this then in rectangular form would be a sub n plus j0, and this would be then plus 0 minus j b sub n. Combining those you get a sub n minus j b sub n. If we rewrite that in polar form, we have then the magnitude would be a sub n squared plus b sub n squared. And the angle would be minus, let's just call it minus theta sub n, where theta sub n is equal to the arctangent of b sub n over a sub n. So we're carrying the sign along here as a minus theta sub n. So we can now say we have a complex constant involving a magnitude and a phase. If we call this constant here the magnitude, call it capital A sub n, and leave that theta there, we can then reassert, this is just the nth term, so we can reassert it into the summation where we have finally that f of t is equal to the dc value a sub v plus the summation on n going from 1 to infinity of a sub n cosine of n omega naught t minus theta sub n. Just quickly looking at this, what we've done is we've used phasors to combine these two sums into a single summation involving another constant, and now rather than having cosine and sine terms, or cosine and sine terms, we have a single cosine term with a phase shift associated with it. So this is an alternative form, perfectly legitimate. Don't know that we're going to use a whole lot of it in this class, but there you've got it.